All right, so our next topic of review is going to be fractions, and we're going to do it in what seems like a unique way, because normally when you talk about math, you start with addition, then you go to subtraction, then multiplication, then division. We're going to start with multiplication, because it really is the easiest one to do, and answers questions easier. But I also have to understand multiplication of fractions to do our next lesson, which is addition and subtraction of fractions. So when I look at it, multiplication of fractions, I just have to ask some basic questions. Can I multiply fractions? And if I can, how do I do it? Well, we've taught this ever since the first month of school. I can multiply fractions, yes. And number two, how do I do it? I just multiply across. And it's where I've always showed arrows anytime I've had a multiplication of fraction question, so that I remember that I'm multiplying straight across. Numerator to numerator and denominator to denominator. So in the packet, they give you several examples of having two fractions, having order of operations of what I do. When it comes down to the multiplication, I'm still just multiplying across. Numerator to numerator, denominator to denominator, and I'm good to go. Now, I'm going to jump right into 3 practice problems to remind us how to do this. These are on your packet. Follow along, fill it out. Now, some of you, once again, you complain that, well, you just talk so much, I don't want to watch the whole video. And once again, all you're doing is hurting yourself, because then when you don't know what you're supposed to do, and I ask you those basic questions that I know I teach in the videos, you can't answer them. So you got to go back and watch it, and then you get frustrated with me. Watch the video, follow along, think about what I'm saying, engage. You can tell me, yes, I watched the video. But if you aren't listening to what I'm saying and you aren't following along in the packet, even though you think you know everything about math, you're missing out on the whole point of this. We're reviewing things that I know you're going to start out next year with in 7th grade. And I want this fresh in your mind, since we haven't done these since the beginning of the school year. So multiplying fractions. Can I multiply fractions? Yes. How do I do it? I multiply across. So I show my arrows with my numerators and show my arrows with my denominators. I multiply my numerators. I get 3 times 1, which is 3. And I multiply my denominators, which is 4 times 5, which is 20. Every time I create a fraction as my answer, I then have to ask if I can reduce. Can I reduce 3 and 20? No, I can't. 3 is a prime number. 3 does not go into 20 evenly. So my answer is just the fraction that I get when I first do the math. Not always going to be the case. When I go to number 2, I can multiply fractions, and I know I'm going to multiply across. So when I take 4 times 5, I get 20, just like down here. 7 times 12, bigger number, and if I can't do that in my head, I pick up my handy-dandy calculator, type it in. That's what the calculators are for, and I'm going to see that I get 84. Well, what ought to pop into your head right away is those are even, and 2 can go into them. But they're kind of bigger numbers. Is there something bigger than 2 that can go into it? What you could do is reduce by 2 and get 10 over 42, which are both even numbers. So you'd have to reduce again by 2. Or you could say, well, my greatest common factor of the 2, or the largest number that would go into both of them, is 4. So if I reduce by 4, 4 goes into 25 times, and 4 goes into 84 21 times. Then when I look at that, I ask, well, can I reduce 5 over 21? Well, 5, once again, is a prime number, and 5 does not go into 21 evenly. So 5 over 21 is just my final answer. 3 is going to be done the same way. I know I can multiply them. I'm going to multiply them across. 3 times 2 is 6, and 8 times 9 is 72. They're both even numbers. So maybe in your head you're thinking I can reduce by 2s, and you could. But then hopefully you would see that when you get the 3 as a numerator and you look at your denominator, that it can be reduced by 3 also. Well, if it can be reduced by 2 and reduced by 3, 2 times 3 is 6. So my numerator of 6 can actually go into both of them. So I'm going to reduce by 6 because 6 goes into 6 one time, and 6 goes into 72 12 times. So my final fraction is 1/12. Now, those of you that don't want to watch the videos, and then you skip around, I got this, it's no problem. I'm reviewing a lot in this video. It might be longer than some of the others that have been over the past 2 weeks, simply because there's a lot to go over in this one lesson. So hopefully you're paying attention. This we haven't done for quite a while. And the last time we had this on homework, which was probably 3 weeks ago, had several of you that couldn't remember how to do this. So when I have a mixed number, I cannot multiply them. And when I get into 2 lessons from now, I can't divide them either. So I have to have them as improper fractions. The way I go about making improper fractions is that 2-step process of multiply and add. I always start at the bottom, so I have to start at the 10, and that's where I've always made that loop with the multiplication sign, because that reminds me I have to start at the bottom and multiply. Well, 10 times 2 is 20. Then I have to add. Add what? The numerator that's there. 20 plus 7 is 27. So I know this becomes a numerator 27, and I always just simply keep my denominator. So my denominator is going to be 10. This is a mixed number also. It also has to be an improper fraction before I multiply. So I got to, once again, start at the bottom and multiply. 3 times 1 is 3, but then I have to add. 3 plus 2 is a numerator of 5. Keep my denominator of 3. Once I have that, then I have my multiplication problem, and then I can move forward with what I just did with the first 3. I know I can multiply, so I'm going to multiply straight across. Well, this is where multiplying straight across gets me some really big numbers that get kind of confusing. So I'm going to not multiply straight across. Instead, I'm going to cross reduce. So cross reducing is looking at numbers that will go into each other diagonally. One numerator and one denominator have to match up. It could be even the same set when I end up with my answer here. But I have 3 that goes into 3, and I know it goes into 27. So 3 goes into 3 one time, and 3 goes into 27 9 times. Well, when I look at diagonally at the 5 and 10, I also know I can reduce those, because 5 goes into 5 one time, and 5 goes into 10 2 times. So now I'm left with just multiplying smaller numbers, which is what my goal always is. I want to multiply now 9 times 1, because I'm multiplying my numerators, and I get 9. And 2 times 1, which gives me 2. But that's an improper fraction. Improper fractions is what I have to have in order to do my math. Improper fractions cannot be my answer. So I have to convert. Once again, the only time I can have an improper fraction like this is if I'm talking about a ratio or a rate, which is not what we're doing here. So I have to convert this. Convert this like a convertible means I have to change it from one form to another. Going from a regular car into a topless car is called a convertible. So when I convert these, I'm going from an improper fraction into a mixed number. What type of math is a fraction? And hopefully all of you, all 24 of you, can now say, well, that's division. So my top number goes inside my box. My bottom number, my denominator, is always my divisor. 2 goes into 8 how many times, or into 9 how many times? Well, it goes in 4 whole times, because 2 times 4 is 8. So what I end up with being left with is that 4.5 is my mixed number, because 2 goes into 9 4 times with 1 left over. My remainder always is my numerator. My divisor is always my denominator. So that's where I get the 1/2. So 4 1/2 is my final answer. So the second part of this review is doing all of those steps that we just did on that last question. Being able to cross-reduce before I do my multiplication. Do you have to? Yes, because that's what this part of the lesson is all about. On your first practice problems for your homework, if you don't want to cross-reduce, okay. But on the second set of problems, you have to cross-reduce, because that's what the lesson is all about. So how can I reduce 4 9ths and 3/14ths before I multiply across? Well, 3 goes into 9, and 4 and 14 are both even. So I know I can cross-reduce both ways. If I start with the 4, it's even, so 2 goes into it. Well, 2 goes into 4 how many times? 2 times. And 2 goes into 14 how many times? Well, 2 goes into 14 7 times. So I know I've reduced those to 2 7ths. And when I look at the 3 and the 9, the 3 is indeed a factor of 9, which was our first review lesson. So 3 goes into 3 one time, and 3 goes into 9 3 times. Now I'm left with basic numbers that I can multiply across to get my numerator, multiply across to get my denominator. 2 times 1 is 2. 3 times 7 is 21. check, just to make sure I didn't miss something on my cross reducing. I could have maybe gone even bigger numbers, but 2 is a prime number. It does not go into 21 evenly, so I know 2 over 21 is indeed my final answer. On number 2, well, 3 is a prime number. It doesn't go into 4 or 5. 2 and 4 will reduce, though, because they are both even. So 2 will go into 2 one time. 2 will go into 4 2 times. So then I'm left with multiplying across 3 times 1 and 2 times 5. 3 times 1 is 3. 2 times 5 is 10. 3 is a prime number. It does not go into 10 evenly, so I know 3/10 is my final answer. Then when I look at number 3, I can see that 3 goes into 6 because 3 is a factor of 6. And 5 would go into 20 because 5 is a factor of 20. So I'm going to cross reduce both ways. 3 will go into 3 one time, where 3 will go into 6 2 times. And then I do my 5 and my 20. Well, 5 goes into 5 one time, and 5 goes into 20 total of 4 times, because 4 times 5 is 20. Now I'm just left with multiplying my numerators of 1 times 1, which is 1, and my denominators of 4 times 2, which is 8. 1 and 8 can't be reduced in any way, shape, or form, so that is going to be my final answer when it comes to my multiplication of fractions. The last part of this review lesson is how do we compare? Well, I asked the same type of questions. Now, notice I've given you some fractions also with decimals in case you have decimals added to it. I made sure I didn't add decimals to your homework assignment, so you don't have to worry about mixing last week's with today's. But just so you understand how it works, you can look at that. But I still have the basic question, can I compare fractions? Yes. But what do I have to have in order to compare fractions? So when I compare fractions, I have to have common denominators, and that's where multiplication has to come into play. Notice on number 1, my denominators are already the same. I already have 2 11s. So that comparison becomes pretty easy because all I have to do is look at my numerators. So when I have a 4 and a 2 with the same denominator, then I just know that my arrow, the tip of my arrow, will always point to the smallest number. 2 is definitely smaller than 4, so it should point to the right. However, when I get to the next 2, I don't have common denominators. So how do we get a common denominator? So when we did these early on, the first month of school, this is where we said, well, all we're going to do is take the opposite denominator and multiply this fraction top and bottom by that number. So this denominator is a 6, so I'm going to multiply top and bottom both by 6s. And this denominator is a 7, so I'm going to multiply both of those by 7. So when I multiply by the 6s, for my numerator, I get 6 times 5, which is 30, and 6 times 7, which is 42. So then when I take this denominator, the 7, and I multiply numerator and denominator over here by it, then I have my 5 times 7, which is 35, and 6 times 7, once again, which is 42. So I have my common denominator, which then says, okay, if I have my common denominator, once again, just like here, look at your numerators. Which one is smaller? Because that's the way the arrow will always point. And the tip of the arrow will always point to the smallest number. So number 3, have denominator of 4 and 5, not common, so I'm going to multiply by the opposite denominator. So I have a 5, so I'm going to multiply numerator and denominator by 5. My new fraction becomes 15, or 5 times 3 and 5 times 4, so 15/20. So then I'm going to take my denominator of 4 and multiply it by this side. I'm going to multiply numerator and denominator, each by the 4, which gives me 4 times 4 and 5 times 4, which gives me 16/20. Now that my denominators are the same, I just look at my numerators. The arrow point, once again, will point to the smallest number. 15 is smaller than 16, so it also has to point to the left. This works in the same way as your next 3 practice problems, which is putting things in order from least to greatest. Now, you have to watch the directions. I'm not trying to trick you. Most of the time, I'm going to say least to greatest, but there are times that the books or your standardized test will say greatest to least. You just have to make sure you read the directions and they are correct. Your homework assignment, if I give you these, are going to be least to greatest. You can rely on that. So when I look at my denominators, I have to make sure I have a common denominator amongst all of them. I have 8, 16, and 4. So I have to find my least common multiple, going back to what we reviewed first when we started the review section. That's why we started with those. My least common multiple of those three numbers. Well, 16 is my least common multiple for those. So I get to keep that one in that form. But I got to change this to a denominator of 16, and I got to change this to a denominator of 16. So I have to ask myself, what am I doing to 8 to get 16? Well, I multiply it by 2. And if I multiply my denominator by 2, I have to multiply my numerator by 2. And so I multiply to get my new fraction. 2 times 3 is 6. 2 times 8 is 16. I got my 5/16. I'm going to keep that the same because that's the denominator I'm going with. And then I use my 4. Well, what am I doing to 4 to get 16? Well, 4 times 4, my basic multiplication. And if I multiply my bottom by 4, I have to multiply my top by 4. So 1 times 4. So my new fraction becomes 4/16. Now, this is where we really struggled at the beginning of the year, understanding what was being asked of us. I have to put these fractions, their original forms, in order from least to greatest. I'm not going to put these in order from least to greatest. That's what I converted them to in order to know their difference. This must be shown on your paper so that I know you understand how I'm comparing them. It's not a guessing game. But I then can use these to put them in order. So 4/16 has a smaller numerator. I have to write 1/4 first. My second one is the 5. That was the original form. So then I put down my 5/16, which says that 6 is larger than the 3. And my original form for that one was 3/8. So these three in this order, in this form, is your correct answer. It's worth 3 points having them in the correct order. So just make sure you show your work. That's 1 point. Each one is in the correct spot. That's a total of 4. All right, so now, when I look at these, this one I was able to use my largest denominator of 16. Can I use my 21? No. Now, the one that they had on there originally, you probably can tell, as I can tell from here, you can tell your paper, this has a different font to it. It had a really large denominator. I didn't want to make it that complicated for you, so I tried to make it easier. But the smallest number that they're going to have in common is if I double this one. So usually if I look at my largest number, and it won't work for these as a common denominator, I have to do multiples of that. So I just multiply by 2. That's the one I went with. So I have 21 that I would be using. So if I take and multiply 21 by 2, and I multiply it, or if I take the 21 and multiply it by 2, then I get my 42. So that second multiple is the one I'm going to use to compare all of these. So I have 2 times the 21, which is 42, and 2 times 4, which gives me a numerator of 8. So I have to change this one into a denominator of 42, this one into a denominator of 42, then I have to put them in order from least to greatest. So what would I do to 6 to get 42? Well, I have to multiply it by 7. And if I multiply my bottom by 7, I have to multiply my top by 7. So 7 times 5 is 35, and 6 times 7 is the 42. So what would I do to the 7 to get 42? Well, if I multiplied 6 by 7, then I'm going to multiply my 7 by 6. So if I multiply my denominator by 6, then I have to multiply my numerator by 6. So now I have 5 times 6 and 7 times 6. So I end up with 30 over 42. And now I got to put them in order from least to greatest, back in their original forms. So when I have my denominators, then I'm looking at my numerators. My first one, this is why I always line them up so I can match them when I go to put them back in their original forms. 8 is smaller, so my first one is going to be 4/21. Well, then when I look at these two, 30 is smaller than 35, so my original form that I'm going to write down is 5/7. And then, since my 35 is the largest, my original form I'm going to write down is 5/6. So showing my work, have them in the correct order, in the correct form, is worth 4 points. Now my final one, number 7. I have to show work on 2 of them, but I'm not going to show work on 1 of them. When I look at those, 1 of them ought to jump out in your mind that it is the smallest number, because the whole number is smaller than the 2 on the other ones. So my first one that I know is going to have to be first is 1 and 5/12, because 1 is smaller than 2 every day. But now I have to compare these. I don't have to change it to an improper fraction because the whole number can stay the same if I'm just comparing. I'm not multiplying them together or dividing them together. So all I have to do is change the fraction part. So if I take and I look at the fraction part, if I just multiply by opposite denominators, like we did with the comparisons, I'm going to get to a comparable denominator. 4 times 6 is 24, and 4 times 1 is 4. So I keep my whole number, that's going to give me a mixed number of 2 and 4/24. When I have my 2 and 1/4, my opposite denominator is 6, so I'm just going to multiply top and bottom by 6. That's going to give me a mixed number of 2 and 6/24. Now I have to be able to determine which one is smaller of the two, and therefore which one is the largest of the entire group. Denominators are now the same, so the 4 is smaller than the 6. So my original form has to be written down as my answer. When I have 2 and 1/6 as the middle number, and 2 and 1/4 as the largest number. So those three answers have to be written in the correct spot, showing work 4 points when I solve my problem. So that is your assignment. Hopefully you followed along and you listened to everything I had to say because I reviewed a whole lot of information and not only went a couple of minutes longer than the other videos. So shouldn't be a difficult assignment if you paid attention. If you have any questions, then you can ask. Okay, seriously, my phone never rang and you terrified me because I didn't even hear you open the door.
Well, I thought you were looking